A lot of applications of quadratic functions come from physics when we have falling objects or projectiles. So let's look at a situation where we have a free falling object, and we know the distance that a free falling object travels is found by this equation from physics. S of t equals 16t squared. So the question is, if you drop a penny from the top of the Empire State Building, if you climb all the way up, you're up here as far as you can get, and you drop a penny down there, and that's 1,250 feet. How long will it take to hit the ground? Well, let's find out. So this is our distance, S of t. S of t is the distance, so we want 1,250 to go in for S of t, and 16t squared. Remember, this is function notation, not S times t. This tells us t goes in, S comes out. So this is our S value. So let's solve this up using our techniques we know. Let's divide by 16. And I'm just going to write it as 1250 over 16 for the moment equals t squared, because now we're going to square root both sides. And we can go to our calculator and enter this whole thing at once. 1250, the square root of 1250 divided by 16. So punching that whole thing on our calculator, we get about 8.838. So about 8.8 seconds. All right, so the time is about 8.8 seconds. Okay, so t would be about 8.84. Okay, so that's how long it would take for that penny to hit the ground for the Empire State Building. So that's a free falling object. What if we have something that's a projectile? So a projectile is something that's launched into the air but is not propelled by anything. It doesn't have an engine or a rocket or anything like that on it. So here's the formula for the initial, or finding the height. S represents the height here. And so S naught, or S sub 0, is the initial height. This is the initial vertical velocity. T is time. G is the acceleration of gravity, which in feet per second squared is 32, or if we're using meters, it's 9.8 meters per second squared. All right, so this is just measuring the vertical height, not really measuring the horizontal. So here we got a situation where we've got a bullet that's shot in the air off a 128-foot building, and the vertical velocity is 320 feet per second. All right, well, let's write a function here. We've got our generic formula. We'll fill in things we know. By the way, you won't need to memorize this function in most math classes here. So, but our function, let's write it out. So here's how we would build it. So S sub 0, or sometimes we call that S naught, is the initial height. What's the initial height here? Well, it's off a 128-foot building, so 128. The vertical velocity is 320, so that's our V naught. So we're starting at 320 t. And then we have 1/2 times g times t squared. G is this constant right here. So we have 1/2 times 32 times t squared. And if we clean that up, we get 128 plus 320 t minus 16t squared. All right. So now let's set this equation to 0 and figure out when it hits the ground. So here's what's going on. We're shooting this bullet off a height, and it's going to come down and it's going to hit the ground. Okay, this path is going to be a parabola. It's a quadratic function. Notice that. So it's quadratic. So we want to know when that hits the ground, when is that 0? So when is 0 equal to 128? Or let me put it in a different order. Negative 16t squared, we'll put it in descending order, plus 320t plus 128. Okay. Now we can plug this into the quadratic formula if we'd like. But we've got this negative 16. I wonder if all of this is divisible by negative 16. I know it's divisible by 2. I think it's all divisible by 4. So let's go ahead and divide everything by negative 16. And that's going to give us 0 equals negative 16 divided by negative 16 is just 1t squared. 320 divided by negative 16 is going to be negative 20t. And 128 divided by 16 is 8. But it's going to be negative because of this minus here. So negative 8. There we go. So there's an equation. Be nice if we could factor that. I think we can. I think 10 times 2 is the magic number. So magic numbers. So we can factor this into t. We need two numbers that multiply to negative 8 and add to negative 20. Oh, wait. I think I reversed that there. So looks like we can't factor it. Yeah, so I think we're going to have to use the quadratic formula here. So using the quadratic formula, we get t equals negative b, which is negative 20, plus or minus square root, and b squared minus 4 times 1 times c, 4ac, all over 2a, which is 2 times 1. Let's clean that up, and we get 20 plus or minus. This would be 400, and then this would be plus 32. So we ended up with 20 plus or minus 432, all over 2. Okay, and that's about 20.78. Get 40.78 on top divided by 2, which would be about 20.39. All right, so we'll take 20.39 seconds. Now, that's the adding version there. We don't need the subtracting. If you do the subtracting, this will turn out to be negative. So by adding, we get that. So it will hit the ground at 20.39 seconds. All right, let's look at one more here. So suppose we're traveling 3,000 feet per second horizontally. So that's our horizontal distance, or speed, I should say. Okay, so if it's traveling 3,000 feet per second, then the distance equals rate times time. So we know it's going to travel with a rate of 3,000 feet per second. And the time is 20.39. And we'll find out what that distance is there. And that gives us 61,170. And that is feet. So that's how far it will travel. Distance equals rate times time. Helps there. All right, that's how projectiles work. So our last application has to do with maximums and minimums. So here we have a situation where the amount of precipitation in Sonoma, California can be represented by this function here. And P of X is in inches. That's the amount of precipitation. X is the number of the month. So like 1 is January, 2 is February, so on and so forth. So the question is, in what month is there the least amount of precipitation? Because we want to find the least. Okay, so what we can do is we can graph this. We'll learn more about functions coming up in the next lessons, but let's go ahead and enter our equation, and then we'll graph it. You can graph this either on Desmos or on your graphing calculator. So we have y equals 0.2. I'll make this larger in just a second here so you can see it better. Just copying that equation, 2.8 and x plus 9.8. All right, I think there it is there. Okay. So the question is, what month do we have the minimum? Well, where does the minimum happen? The minimum happens right here in this lowest point. It's called the vertex. So that at 7, 0, all right, that's at 7, 0, there's the axis. So at 7, 0, it hits the x-axis. That's the lowest point. The x-axis doesn't have much to do with it, actually. So 7 would be in July. So in July, it has its lowest point. So in July, the function has its lowest point, which would be the vertex, we call that. That's where it turns around. That would be the least amount of precipitation in July. Okay? All right, well, here we got a situation where old MacDonald had a farm. E-I-E-I-O, right? Okay. And so on that farm, we got some pigs, and he's going to make a rectangular pen for his pigs against the barn. That's important. So it's rectangular, and it's against the barn. And then we got some important facts. He needs the fence to be, we got 3 sides of the pen, so we're going to fence in 3 because one side will be against the barn. And we've got 80 feet of fencing that he wants to make the pen out of. What is the largest area now? So what is the largest amount of area for his pigs? Okay, so let's draw a situation. Drawing will help a lot. Kind of a bird's eye view here. Here's our barn. And we're building an enclosure here. And so we got 3 sides. We've got a width and we've got a length, right? Okay, and so we know that the length and the width have to add up to 80. In fact, we've got 2 widths. So we know that 80 feet of fencing, 80 feet, has to be equal to 2 widths plus a length. Okay, 1 length, because there's only one long side. The other side's up against the barn. Okay? And we don't actually need the feet in there. Let me take that out there. All right. Just 80 equals 2L, 2W plus L. All right. So we want to find the area. So what we need to do is we need to solve for L in this case. So if we subtract 2W from both sides, we have the length is 80 minus 2W. You could also solve for W, but that's going to be a little trickier. So now, how do we find the area of this? Area is length times width, but we know an expression for the length that we can put in there. Okay? So we want to maximize this area, so we don't know what the area is, but we know that we have 80 minus 2W, that's going in for length, times the width W. So we're just going to copy that width down. Copy everything down and fill the length with this expression. So we're going to distribute the W. And so 80W plus, actually minus 2W squared equals 8. All right. So now that's a quadratic equation. We want to solve it. So we can graph this. And we want to find the largest area. So we're going to go graph this now at 80W minus 2W squared. So we're going to go to our graphing calculator. So when we graph this, we got this blue line going up here, but we don't quite know what it is, so we got to zoom out. So I'm going to hit the zoom out over here. Oh, there it is. Okay. So we're going to scrolling up. Where is the peak of this? So at the top, we can tap it. We know that when the width is 20, we get an area of 800. So that maximum, that's the highest point that happens when the width is 20. When the width is 20, the area is 800. And this is in feet. This is in square feet. So our final answer is with a pen. So the pen would be 20. And now we got to find L actually here. So let's take this equation. And L is 80 minus 2 times 20. So that's going to be 80 minus 40, which is 40. With this, so we have a 20 foot by 40 foot pen. we get the largest area of 800. And that would be 800 square feet, right? Yes, square feet. Okay. And there's our final answer. All right. So again, we draw a picture. We write an equation that we know, area equals length times width. And then we're going to connect. We're going to take the extra information to connect length and width here like this. All right. Hope that makes sense. Hope that helps. Keep it up there. Sometimes these application problems takes a little bit longer, but if you organize it out, if you draw pictures, take the information, write it out, keep that organized, and try to use formulas where appropriate, then that should work good for you. All right, so keep it up. Thanks a lot.